we are going to do 3-1, and that is going to cover our basic identities.
No.
Okay, well, get ready. I don't want to listen to the Puppy Monkey Baby remix. Okay, so again, you already kind of are familiar with these guys. So,
except you knocked down the green one.
yeah.
It doesn't matter. That makes it kind of cooler.
Okay, so your main reciprocal identities. Let me make sure you write reciprocal. Your reciprocal identities, sine of x is equal to 1 over cosecant x. So we already know these. We're just going to now just call it, I think we even called it an identity then, and you'll see we will just be rewriting lots of stuff using these identities. So next one, cosine and secant. So I'd have cosine of x is 1 over secant. And secant of x is 1 over cosine. Okay, tangent, cotangent go together. Tangent of x is equal to 1 over cotangent x. Cotangent x is equal to 1 over tangent x. Okay. Tangent. Okay, we're also going to have more identities, and that we're just writing sine or tangent and cotangent in terms of sine and cosine. We've also already done that. We just want to make sure that we have a nice place to keep everything kind of handy. Okay, so another way to write tangent of x is sine over cosine. So you write sine of x over cosine x. Make sure you still write the x or whatever letter they would happen to have with it.
This one's planar.
Cotangent x is equal to cosine x sine x over sine x. Okay, so now I just kind of want to show you where some other things are kind of coming from. We had used before, we had kind of already gone through a proof to show that sine squared of x plus cosine squared of x is equal to 1. So we've done that. We have seen that. So what I want to do is I want to rewrite it. So this came from x squared plus y squared equals r squared is where the original thing came from on a unit circle. Now with that, I just want to rewrite this in a couple different ways and show you how rewriting it can get you a totally different equation. So instead of sine squared x, I'm going to divide everything by sine squared. Okay, so I can just, it's like you're acting like you're solving for it, but we're not even actually solving for anything. We're just dividing everything on both sides. Okay, so what that gets us is 1 plus, what's cosine over sine? Cotangent, so that's going to be cotangent squared of x. So do you kind of see how we can combine those things? So since they were both squared, we got to do that. 1 over sine. What is 1 over sine? Cosecant, so it's going to be cosecant squared because the sine had a squared on it. Okay, so this was our main identity that we started with. So these are all going to be called Pythagorean identities. And so then I can also do the same sort of thing when I start with, so this is a nice one that we're going to keep. We're also going to do the same thing and get with we're going to divide by cosine. Sorry. Sine squared of x plus, I'm starting a totally new one, okay? So that is one that we're just going to keep handy. Plus cosine squared of x equals 1. Divide everything by cosine squared. And you're not usually going to have to actually do this division. I just want you to see where these things are actually coming from. So then sine over cosine is tangents squared of x. Cosine over cosine is 1. And 1 over cosine. 1 over cosine is secant squared of x. Okay, and usually you see that one. Yeah, that's how they write it here. So we have sine squared of x plus cosine squared, or sine, oh my gosh, I can't talk. It's going to be a rough day. Sine squared plus cosine squared equals 1. Then I have 1 plus cotangent squared equals cosecant squared, and tangent squared plus 1 equals secant squared. So those are all our Pythagorean identities. Pythagorean. Okay. Okay, so Pythagorean, remember that's just coming from actually like if I was thinking about it in a triangle, a squared plus b squared equals c squared.
What are you selling pops for?
I will sell them for 50 cents after this weekend in our last game. Then we're also going to list what we call odd and even identities.
I didn't believe I'd fuck it that way.
You did. You did.
You done did.
Okay, so odd and even identities. So the odd ones are that if you have the sign of a negative angle somewhere given to you, you can rewrite it out front as negative sine x. So you can go both directions with this, okay? So if you had a negative sine x, you could rewrite it as sine of negative x. Okay, so then cosecant and sine, really like they're always like 1 over each other, so they go together with everything. So cosecant of negative x is equal to negative cosecant of x. Okay, tangent and cotangent are going to have the same sort of relationship. So if I would give you tangent of negative x, you are going to have negative tangent of x. And cotangent of negative x is equal to negative cotangent x. Okay, so those are all my odd ones. My even ones are cosine and secant.
Sin is an abbreviation for sine.
Then why can't I say sin?
I don't know, but it kind of annoys me.
Well, fuck.
I've been saying sin since like 2 years ago. 3 years ago.
Yeah, you should say sine.
No, it's sin.
So
Maybe
what,
you
you
should
just
put an
say-
E on the
You
end.
just say ksk too?
Yeah, you say ksk.
No, I don't even pronounce it. Otherwise, fuck 'em.
CSC.
I say cot
Yeah.
and tan instead of tangent.
Okay, so for the even two, so if I have cosine of a negative x, it is just equal to positive cosine of x. Okay, your other even one is secant of negative x is equal to positive secant of x.
Why do you hate me?
I kind of feel bad. I broke my jaw still. I just still have one of my straws in my pickup, but I have like a whole box in there.
So now to simplify, so it'll ask you to simplify, yep, it says write each expression in terms of sines or cosines and then simplifies how everything is kind of worded for you. So this first one is sine of negative x times cotangent of negative x. Okay, so this will be some of the things that you'll have to do. And so sine of negative x, I'm going to bring that negative sign out front for sine and cotangent. Did I say ax? Did I say ax?
No,
Okay.
we're talking about the sin and
That's just
sine.
Okay.
illiteracy.
Yeah, it does bother me too. Okay, so sine, so I have negative sine of x times cotangent x,
Economy.
negative cotangent x. Okay, so then when I have a negative times a negative, these guys will actually get to multiply out to make a positive here and here after you brought them out front. So this is kind of like the process that you're actually going through, okay? So this is actually what a problem would look like. So sine, is that already written in terms of sine or cosine? Yes. Cotangent. Cotangent is not in terms of sine or cosine, so I have to rewrite it. So I brought those negatives out front, and then I had a negative times a negative, and I made it positive. So then I have sine of x times cotangent. How else do I write cotangent?
Hot.
Cosine over sine. So then I'm going to write, instead of cotangent, I'm going to write cosine of x over sine of x. Okay, what's sine x times cosine over sine? I'm going to treat it like a fraction here, and then I'm going to cross off my signs. So then my total simple answer is just cosine. Okay, so that's pretty much along the lines of what we're doing with everything, is we're just getting everything simplified as much as possible. Okay, the next one is grosser. Yep, just grosser. Okay, the next one is 1 plus, or 1 over, what?
There was a comment
Yeah.
that said, the house is clean now, but her panties are all dirty. It was hilarious.
All the way.
Okay, so when I have cosine of a negative, oh, sorry, I didn't realize. I thought this was like 2 separate problems. This was really just one problem. So this is the rest of the problem that I just couldn't read.
Time for my arithmetic.
Okay, it really was a plus sign in there. I just didn't read that. Okay.
Arithmetic.
Exactly.
Okay.
People.
So now, one cosine of a negative number is just plain old cosine. So I have 1 over 1 plus cosine. And your goal here, when you see something like this, is to add them together. I can't add them together right now because they don't have the same denominator. Okay, so we have to multiply by what each denominator needs to get that common denominator. I am mumbly. Okay, so this one needs the 1 minus cosine. This one over here needs 1 plus cosine. So this one needs the 1 minus cosine. 1 minus cosine. 1 plus cosine. 1 plus cosine x. I keep not saying cosine x, and make sure that your cosines always have the x's or whatever thing is in there with it. Okay, so on top, it's nice multiplication that I have 1 times 1 minus cosine x plus 1 plus cosine x. On bottom, I actually have to FOIL this out, okay? So multiplying through these things. So I have 1 plus cosine x times 1 minus cosine x. So I have 1 times 1 is 1. 1 times that is negative 1 cosine x. I don't have to write the 1. You can if you want to. Plus 1 cosine x. I did write it that time just because I said it. Plus cosine times cosine with a plus and a minus is going to be a minus. Cosine times cosine is cosine squared. Okay, so on bottom, these two add to 0. I have a negative 1 and a positive 1 cosine x. So on top, I'm going to add like terms where I can on top and on bottom. On top, I have a negative cosine x and a positive cosine x. Those add to 0. 1 plus 1 on top is 2. Over on the bottom now, I have 1 minus cosine squared. And now what I also want you to be able to recognize, so we'll go through and rewrite these guys all differently as well from your Pythagorean identities. Your 1 minus cosine squared, I want you to recognize that as the same as sine squared. So if I had this equation, and if I subtracted cosine squared from both sides, can you see that? No? Nope, nothing. Different color. Okay, so if I subtracted cosine squared from both sides, over here I would have it equal to sine squared. So then I'd have sine squared equals of x equals 1 minus cosine squared. Okay, so that is one of the different versions of your Pythagorean identities that you'll see. So these are your main 3 ones. But anytime you see it with a squared, go back and look and see, does it look anything like any of these guys? So 1 minus cosine squared is sine squared. So I have 2 over sine squared x. At this point, I would be okay a little bit with you leaving it like this. Also, you generally don't like sines and cosines left over on the bottom. Like we try to get it out of the top. So I could rewrite it as 2 times 1 over sine squared of x. 1 over sine squared of x is cosecant. So I have 1 over cosecant squared.
I can't fucking wait.
or not 1 over, just cosecant squared.
I'm pissed off.
2 times.
If I
So
thought
2
that-
times cosecant squared. So then that's what your final answer would look like. And that is going to be, so cosecant of negative x times tangent of negative x.
Finally, bro.
Dang it.
Okay, so cosecant of negative x goes to negative cosecant of x times
Yeah.
negative tangent of
Just 'cause I'm
regular
a nice
x.
guy. Okay.
That becomes positives. So I need to rewrite everything in terms of sines and cosines.
getting you another straw, right?
After you broke the other one? We're wasting your straws.
I see that. Okay, so then I just have regular cosecant x times tangent
You
x.
have straws.
I build thing out of for different
That's true.
classes
And
sometimes.
that's what I mean.
Okay, so cosecant, I'm a hoarder, yeah. Cosecant is 1 over sine.
Randy gets praised for telling the truth.
Tangent is sine over cosine.
That's because you're a felon.
Yeah, true.
Sines cross off. 1 over cosine of x can be written as secant. So secant x would be what your answer would look like.
Can't believe you actually found it. It's kind of sad.
Yeah, that's bullshit.
Our
'Kay.
legal system
Sum.
Oh yeah.
Because you couldn't pay what, like a $200 fine?
It was $1,200.
And then, so 9 through 24, 31 through 40. Let me show you what 19 looks like. So 19 says express cotangent of x in terms of cosecant. Terms of cosecant. CSC of x. So the only equation that we have, so we go back and look at our equations, so we're looking for cotangent and cosecant. So cotangent does not have a cosecant in it. Okay, so then I look for my Pythagorean identities. Cotangent and cosecant are in this one. So I have 1 plus cotangent squared x equals cosecant. So I have 1 plus cotangent squared of x equals cosecant. So I just find the only equation that I can find. What?
This is number 19.
Yeah, this is number 19.
Why are we on the
I just want you to show there's like 6 of them that are like this, and I want you to see how to go through it. Okay, so I find the only equation that can relate these two. That's a CSC, not CSS. Okay, so then I have 1 plus cotangent, so express cotangent. So now I need to solve for cotangent. So I'm going to subtract 1. Then I'm going to take the square root. Okay, so your answer is not that bad, and it does not take that long. So I just have cotangent of x is equal to the square root of CSC squared x minus 1. Okay, so you just need to solve for it all the way. What in tarnation? So that's what those will look like.